velocity against time, right? So, and then you have this motion, right? Then you have this motion, right? So if you have this kind of curve or motion, right? So the motion is uh, move like this curve, all right? So you want to find the area under the graph, all right? So why we want to find the area under the graph? Because usually we want to analyze. Usually it represent the displacement, right? Usually it represent the displacement of area of displacement. So if you find the area under the graph, you will find the displacement. All right. So how are we gonna to calculate the area under the graph? All right. So under the, because the graph, the area is not really a triangle, right? It's not it's not the shape is not really the shape is complex. So how are we going to calculate that? All right. All right. So in this chapter, you will try to explore the relationship between the antiderivative and the finite integral, and discusses families of curves. Curve. All right. So we will try to find the relationship. What the relationship between the indefinite integral and the antiderivative. All right. So this is the topic covered in this chapter. All right. All right. Before that, why we want to study the sign area, area as a sum, because it is crucial. For example, especially in maths and STEM itself, in science. All right, because we want to understanding. First of all, we want to understand the integration. All right, so the integration is we will introduce the concept of integration in this chapter. All right, then we will try to approximating a complex shape. All right, so we will try to analyze actually the complex shape. All right, because in nature we have a different type of shape. So the shape is very, sometimes the shape we found is very complex. So usually we're using maths to calculate. All right, so especially we want to calculate the area of the shape itself. All right, then you want to dealing with the changing rates. All right, because in the previous chapter in the derivative, right, we calculate the changing rates, right? So now we want to analyze the changing rate, but in different in the reverse algorithm. All right, in the reverse map. All right, then we want to, so, and also the sign area as a sum also have application in physics and engineering and also science. All right, then we want, and then lastly we want to analyzing function. All right, especially function. All right, so before this we use a derivative to analyzing function. Now if we have a derivative, if we have a derivative, right, so how are we going to try to reverse it to the original function? All right, okay. Then we split it into multiple fringe. This is what we call as a fringe. So this is what we call a fringe here. So we split into multiple fringe. So assume that all the fringe have the same area and size. All right. All right. So the fringe we separate into from the curve is from A to B. All right. So actually, we want to find the area under this curve actually. So we want to find the area for this curve from A to B. But how we going to find the area? Actually, we will split this area from A to B into the split fringe. All right, multiple fringe lah, multiple fringe. All right. So and then we pick one area. All right. So we pick one fringe. All right. So then we pick one fringe. We call it as the derivative of A here, derivative of A. So part of area, actually part of area from, and then this derivative of A actually is from x until x plus derivative of x. All right. So this size actually is the derivative of x here. All right. So we pick one. We choose one specifically. We choose one fringe. All right. And the total area. So we know that the total area of the hole from A to B is a multiple. Is you need to times multiple. You need to add up all the fringe from fringe A, B, C, from all the fringe. All right. So you need to add up all the multiple fringe. Then you will get the area from A to B. All right. So it will become a series here like this. All right. So it will become a series. So multiple A here. So assume that all the size of this fringe is all the same. Assume that. All right. So that means all the summation of this fringe will become the total area of A. All right. This means the total area under the curve. All right. All right. So and when, all right. So when fx is approaching to 0, actually it's approaching to 0, and fx, when the x here is derivative of x here is approaching to 0, so it will become fx, the derivative of A will become the derivative of x times fx. All right. So that means we can conclude that. All right. So that means that we can conclude that the side area. All right. So limit, because when derivative of x approaching 0, because we don't know the difference between the how much the size actually. So we don't know the size. So the limit of derivative of x approaching to 0, actually it's a series of fx. It's the summation of fx times derivative of x. All right, derivative of x. All right, bear in mind the derivative of x is equal to b minus a over n. All right. All right. So we can conclude that this is the sign of area of the sign area, the total area of A. All right. So how we're going to find is the limit. Actually, is from the limit derivative x approaching to 0, summation a summation a to b times with fx with derivative of x.